Hi, mathletes. In this lesson, we are looking at equations of lines in slope-intercept form. After this video lesson, you will be able to graph and write equations of lines that are in slope-intercept form. Let's talk about what it means to be a y-intercept. This might be familiar to you. And in the previous section, hopefully you noticed that the underlined numbers on the last page were all numbers on the y-axis. This is called a y-intercept. It's the point where the graph crosses the y-axis. In the graphs below, so these three graphs right here, you are going to label the y-intercept with its point. And that point, if it's on the y-axis, what is the y value when it is on the y-axis? It's always 0. And so so you'll only be filling in where it crosses the y-axis as the y value. So for here, for example, the y-intercept is right here. The x is not changing. It's on the y-axis. It doesn't go right or left at all. It just goes straight up. And so that would be 0, 1. You are going to do that for the next two. Let's take a look at these questions down below. So for each equation below, identify the slope and the y-intercept. So again, using what you did on the first four graphs, hopefully you have a solid understanding of what we're looking for when we're talking about the slope and the y-intercept. So the y-intercept is what is being added or subtracted to the variable. And so I can look here, I see +2, +5, -7, +3/4. Here, my variable is over here. This is my variable. It's in the spot that we normally see what is being added or subtracted, or the y-intercept, but that y-intercept is actually right here. In this particular one, there is nothing being added or subtracted, so you could think of that as 0. So you could think of this as kind of +0 when we write that in. And for this last one, there is no variable x, and so this constant. So the y-intercept is always the constant, the non-variable part being added or subtracted in our equation. So our y-intercept is what I've highlighted in yellow. I'm going to highlight that here just to make that connection. So when we're writing what our y-intercept is, I'm going to write that as an ordered pair. So our y-intercept here is 0, 2. So for number 6, y equals 1, 6x plus 2, it's going to cross the y-axis at 0, 2. For 7, it's 0, 5. Complete the y-intercept for these remaining values. Remember, we've already highlighted them here, so write them as an ordered pair in the spot to the right. Hopefully your values match mine. Now we're going to take a look at slope and where we see that in a given equation. So you talked before, the coefficient of x is the slope value from an equation, and hopefully you saw that in those first four graphs you did using Desmos. So the first thing I'd like us to do is highlight the coefficient of x in the problems right here from 6 through 12, if there is one. They don't all have one. There's some tricky ones towards the bottom. So the 1/6 is my coefficient of x. It doesn't include x, it's just the number in front of x. And so that means that my slope for that problem is 1/6. My rise would be 1 and my run would be 6. For the next one, the coefficient of x is -2/5. That means my slope is -2/5. So I would go down 2 to the right 5, or my rise would be -2 and my run would be 5. And you're going to keep going through the table and highlight. If you don't have a highlighter, you could circle the coefficient of x and then write its slope on the corresponding line. So looking here, you can see I've highlighted. Now this last one, y equals 15, there was no variable x. And so 0 times x is still 0. So I think of the coefficient of the x value being 0. And so my slope is 0 for that particular one. That was a little bit of a tricky one. The sign goes with the value. So if you have a negative here, or if you have subtract, like when you have these reversed, you would still write that as a negative. The bottom half of your page is the same as the top half, except for instead of saying slope and y-intercept, we say m and b. And those are the variables that represent those concepts. So the slope of a line we've talked about before is represented by the variable m. The y-intercept of a line is represented by the variable b. The x and y they stay as variables in the equation. So you can see here the slope of a line, coefficient of x, just like we did when we called it slope. That's what m is. It is represented by slope. And the b value is what is being added or subtract, and that is another way of saying the y-intercept. You are going to write your y-intercept also as an ordered pair. You will complete the rest of this page for practice. The last page of this lesson is some practice for you to do. There's key information given, and you have to match it with the graph on the top section, and the key information is given here, and you're going to write the equation in the blank section. And so we're just going to go over one in each section to make sure that you understand what you're supposed to do. So I'm going to zoom in here, make it a little bit bigger. So on this top section, you can see that the given up here at the top, slope was 3 and the y-intercept is 1. You can think of that y-intercept as 0, 1, or you know that the b value here is over 1. If the slope is 3, that's the coefficient of x, and so you draw a line to connect there. On these other ones, for example, the orange, slope is 1/2. So you're looking here, do you see a slope of 1/2? I do. I see one here. One is negative, one is positive. This is a positive, so we're going to go with the positive one, and that is down here. And you can see that the y-intercept is 4. You got to check that out, and it does match up. Some of them you will need to simplify first. So for example, y equals negative 4 over 2. I don't see any slopes with negative 4 over 2, but hopefully you can see here that the slope can be reduced, and that negative 4 over 2 is the same thing as negative 2 over 1 or negative 2. And so that should be easier to find. You're just going to draw a line connecting the correct key information that matches one of these given equations. So when we look, and it'll be the same thing when you look at this section over here. Looking at the bottom section, you are going to write the equation in slope-intercept form given this information. So the first one was done for us. Y equals, the slope is 2, so 2x minus 1. We know it's y equals mx plus b. If you wrote y equals 2x plus a negative 1, that would be okay too. That is the same thing. Let me zoom in just a little bit to make it easier to write. It would be equivalent to say y equals 2x plus a negative 1. You just don't usually see that. Sometimes I put, when I'm adding a negative, I sometimes put that in parentheses just to make that easier to see. For this green one here, you always start with y equals. My slope is negative 4, x minus 6. And again, you can put plus a negative 6. I think it's cleaner to write negative 6. As you mature as a mathematician, you will write it as subtract 6 instead of plus a negative 6. So finish this page. You're going to complete this page. In summary, slope-intercept form of a line, you have a given equation, y equals mx plus b. The x and the y are your variables, and they stay as variables. The slope of the line is the coefficient of x, and the y-intercept of the line is the constant. That means there's no variable attached to it, next to it. When we look, and the y-intercept is where your line, so this is my line in this example, crosses the y-axis. You can see the y-axis is the vertical axis, it's labeled there. And it crosses at -1. The x value is 0, the y value is -1. To find the slope of this line, you find any 2 points along the line. It's best if you're hitting at a grid mark. That's really the only way you can count it accurately. And so you can see that I'm rising 3 units. So that's where the +3 comes from. I'm running 2 units. That means our slope for this line, our m, is going to be 3/2 because it's always going to be rise over run. Slope is always rise over run because that's the same as the change in y over the change in x. So that up and down change over the horizontal change. And so to write it as an equation, y equals, that's our m, is 3/2 x plus -1. Now, most of the time, you're going to see this as 3/2 x and then just -1 since I'm below the axis and I have this negative value right here.